Welcome to MRL. In this learning session, we'll study the solutions of quadratic equations examples of exercise number 4.1 of 10 CBSE NCERT book. Now the first example given here is to check whether the given equations are quadratic equations. Now the first example is x plus 1 whole to square is equal to 2 in the bracket x minus 3. Now to know whether it's a quadratic equation or not, we have to write it in standard form ax square plus bx plus c equal to 0. So let us simplify it first. So expansion of x plus 1 whole to square is x square plus 2x plus 1 equal to 2x minus 6, because a plus b whole to square is a square plus 2ab plus b square. I have used the identity there. Now x square as it is, 2x as it is, take 2x to the left, it becomes minus 2x, plus 1 as it is, take minus 6 to the left, it becomes plus 6 equal to 0. Therefore 2x to 2x cancels here, plus 1 plus 6 is plus 7. Therefore we get the equation x square plus 7 equal to 0, which is 100% polynomial equation of second degree, and therefore it is a quadratic equation. Now coming to the second example, we have been given x square minus 2x is equal to minus 2 in the bracket 3 minus x. Now simplify it. Minus 2 into 3 is minus 6, minus into minus is plus 2x, and bring all the terms to the left, right in standard form. X square minus 2x plus 2x becomes minus 2x, minus 6 becomes plus 6x equal to 0. So x square minus 4x plus 6 equal to 0. It is a second degree quadratic equation, and therefore it is a second degree polynomial equation, and therefore it is a quadratic equation. Now come to the next example, x minus 2 in the bracket x plus 1, x minus 1 in the bracket x plus 3. Now simplify this, multiply x minus 2 into x plus 1, so x into x is x square, then minus 2 into x is minus 2x, x into 1 is x, and plus 1 into minus 2 is minus 2, x into is x square, minus x, and 3x and minus 3. Now bring all the terms to the left hand side, simplify it, x square minus x square minus x minus 2, x square plus 2x minus 3. Bringing x square to the left, we get x square minus x square minus x minus 2x minus 2, and minus 3 becomes plus 3 to the left, and that is equal to 0. So that is equal to minus 3x plus 1 equal to 0, because x square can cancel here. Now it is a polynomial equation of first degree, therefore it is not a second degree polynomial equation, therefore it is not a quadratic equation. Now next example is x minus 3 into 2x plus 1 and x into x plus 5. Now simplify this, x into 2x is 2x square, and 2x into minus 3 becomes minus 6x, 1 into x is x, and 1 into minus 3 is minus 3, x into x is x square plus 5x. Now bring all the terms to the left, we have got 2x square here, minus x square, minus 6x, bring to the left minus 5x, minus 3, and x as it is here. Now simplify it, 2x square minus x square is x square, minus 6x minus 5x plus x becomes minus 11x plus x minus 10x, and minus 3 equal to 0. It is a second degree polynomial equation, and therefore it is a quadratic equation. Now coming to the next example, now we have been given here 2x minus 1 into x minus 3, x plus y into x minus 1. Now simplify this, open the bracket first, 2x into x is 2x square, and 2x into minus 3 is minus 6x, and minus x, and minus into minus is plus 3, x into is x square, then we have x into minus 1 is minus x, and 5 into x is plus 5x, plus into minus is minus 5. Now bring again further simplify it first, so it is 2x square minus 6x minus x is minus 7x plus 3, x square minus x plus 5 is plus 4x and minus 5, and now bring the term to the left hand side, we get 2x square, x square becomes minus x square, minus 7x as it is, and take plus 4x to the left, it becomes minus 4x, and plus 3 as it is, minus 5 becomes plus 5 equal to 0. Now simplify it, 2x square minus x square is x square, minus 7x plus minus 4x is minus 11x, plus 3 plus 5 is plus 8 equal to 0. Therefore we get x square minus 11x plus 8 equal to 0. It is a second degree polynomial equation, and therefore it's a quadratic equation. Again, a very simple way of proving it. Now the next example is x square plus 3x plus 1 and x minus 2 whole to square. Now apply the identity here, a minus b whole to square, that is a square minus 2ab plus b square, therefore we get x square minus 4x plus 4. Now bring all the terms to the left, we get x square minus x square plus 3x, minus 4x becomes plus 4x, plus 1 plus 4 becomes minus 4 on LHS equal to 0. Simplifying, we get 7x minus 3 equal to 0. It's a polynomial equation of first degree, therefore it is not a quadratic equation. Now the next example is x cube minus 4x square minus x plus 1 equal to x minus 2 whole raised to cube. Now expand this using the identity a minus b whole raised to cube. A minus b whole raised to cube is equal to a cube minus 3a square b plus 3ab square minus b cube. Use that identity, simplify it, and get the final result as 2x square minus 13x plus 9 equal to 0, which is a polynomial equation of second degree, and therefore it's a quadratic equation. Now come to the next example. X plus 2 cube is equal to 2x in the bracket x square minus 1, and now here you have to apply again a plus b whole raised to cube. A plus b whole raised to cube is a cube plus 3a square b plus 3ab square plus b cube, and that is equal to 2x cube minus 2x. Now apply that identity, we get x cube plus 6x square, okay, and plus 12x plus 8 is equal to 2x cube minus 2x, and simplify this, we get minus x cube plus x square plus 14x plus 8 equal to 0. It is not a second degree equation, rather it is a third degree equation, and therefore it is not a quadratic equation. Remember that. Now we have to frame a quadratic equation of the given statement. We have to frame a quadratic equation of the given statement. Now what is the statement given to us? See, there is a rectangular plot and the area of that plot is 528 meters square. The length of the plot is L and the breadth is B, but the length is 1 more than 2 times the breadth, that is it is 2B plus 1. Now we know that area of a rectangle is A is equal to L into B. That means 528 is equal to L is 2B plus 1 into B, that is 2B square plus B. So we get 2B square plus B minus 528 equal to 0, which is a quadratic equation. Now we can find B from this equation. We can find B from this equation by going for middle term splitting method. Once we know B, we can also find L, and L is equal to 2B plus 1, so L can be found out. Therefore we have framed an equation, and from that equation we can find the length of the rectangular plot and also the breadth of the rectangular plot. So that is how we frame an equation to find the two unknowns. So please remember that. Now the second example is, we are given a product of two consecutive integers, and that is 306. We do not know both the integers. Let us assume one of the integers as x, thus the next consecutive integer is x plus 1. We are given the product is x into x plus 1 is equal to 306. We get a quadratic equation. We can solve this quadratic equation to get x, that is one integer, and also we can get the second integer, that is x plus 1. Now the next example is, now they have given the Rohan's present age is x years. Please understand, Rohan's present age is x years and the mother's present age is x plus 26 years. That means now it is given that Rohan's present age is x and mother's age is 26 years more than Rohan, therefore it is x plus 26 years. But that is the present age. Now after 3 years, Rohan's age will be x plus 3 years and mother's age will be x plus 26 plus 3, that is x plus 29 years. Now Rohan's age, please understand, they have given after 3 years, the Rohan's age when multiplied to mother's age, it is 360. And therefore when I multiply x plus 3 into x plus 29, that is equal to 360. When I simplify it, I get a quadratic equation, x square plus 32x minus 273 equal to 0. And if I solve this, I'll get x and I'll get the Rohan's age. And from the second relation, x plus 26, I get the mother's age. So that is how we frame an equation to get the values of the unknown. Remember that. Now here in this next example, we have been given the distance traveled by train is 480 kilometers. We have to frame an equation. Please understand that. We have been given that the distance traveled by a train is 480 kilometers and the speed of the train, that the normal speed of the train is u kilometers per hour. And the time taken therefore is distance upon speed, that is 480 divided by u, but natural, because we know that time is equal to distance upon speed, and that is 48 upon u. But now if the speed is changed, that means the speed has become less by 8 kilometers per hour. The new speed is u minus 8 kilometers per hour, and therefore the time taken will be 480 divided by u minus 8. So now we have time t2 and time t1, but we have been given that when the speed is decreased by 8 kilometers, then it takes 3 hours more. That means t2 minus t1 will be equal to 3, or 480 by u minus 8 minus 480 by u is equal to 3. Please simplify this, and the simplification is very easy. Multiply throughout by u minus 8 into u. Take the LCM of the denominator, multiply throughout by u minus 8 into u. You will get that u minus 8 gets cancelled, so it becomes 480u. u. Here u gets cancelled, so 480 into u minus 8, and here 3 is multiplied by u and u minus 8. So simplify this, that means 480u minus 480u plus minus into minus plus, that is 3840, that is 3u square minus 24u, and taking this to the left hand side, we get 3u square minus 24u is minus 3840 equal to 0, or dividing by 3 we get u square minus 8u minus 1280 is equal to 0 is the required quadratic equation from which we can find the unknown, that is we can find the speed of the train. The speed of the train can be found out. So please remember, so that is how we frame the quadratic equations of any given statement. And remember, by reading the statement, you should understand the statement, break the statement into small parts, understand the statement, and then choose one of choose the unknown value as x or any any variable, and then frame the equation understanding the statement. Once you frame the equation, we can solve the equation to find the unknown values. Okay, so please remember this, learn this. It is slightly typical, and very much these questions are asked in the examination for solving. So learn them, practice them, and write down these examples in a book, practice them again and again, and also solve many more examples of similar nature, and okay, so that you get thorough with the subject. Okay, thank you.